Graphing rational functions, section 6, graph. So there's been 5 sections, 5 lectures prior to this, all prepping you to graph rational functions, and we're finally ready to actually graph them. We had a video focusing on the domain and vertical asymptotes, and then we had holes, and then horizontal asymptotes, and slant asymptotes, and x and y intercepts. So finally, we're now ready to put it all together and graph rational functions. So here's our first example, and you'll see the way that these problems are going to be set up in class and on the exam and stuff like that, where I'm going to give you a problem and space to do all your work, and it's going to say all this. Let me just get rid of that. Move that down there. Let's see here, make sure my settings are good to go. So like it says here, show all your work here. So in this space, all up here is where you're going to do all the calculations and everything, and then down here you're going to fill in all the information as far as domain, holes, yada, 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 and then we're going to graph it. Our calculators will be very helpful as they've been throughout this entire unit, so make sure you have that available for you. So let's jump right in. The first thing we're going to do is factor. Factor the numerator, factor the denominator. So this has a trinomial factoring in the numerator of x minus 3 and x minus 4. The denominator is a difference of 2 squares, x plus 3 and x minus 3. And right away I can see that x cannot equal negative 3 and x cannot equal positive 3. Now, yes, these are going to cross out, but still x can't equal 3 because 3 will make this 0, and that'll give me an undefined term. So right away, before I do anything, even before I cross these out, I could just see what's down here, see what would make each of these terms 0, and that's what's going to allow me to state my domain. And so my domain is all x values from negative infinity to negative 3, and between negative 3 and 3, not including negative 3 and 3, but every number between, and from 3 to infinity. Okay, but now I do see that these do cross out. These minus 3 terms cross out, and that leaves us with a final expression of x minus 4 over x plus 3. So the fact that I have a term that crossed out, this x minus 3 crossed out, that gives us a hole at 3. Because they cross out, it's not a vertical asymptote, it's a hole, and so we have to figure out the y value of that hole. So you're going to plug 3 in for the x values that's left over here, and we'll end up with 3 minus 4 over 3 plus 3 gives us negative 1 over 6. And so this is the y value of the whole negative 1, 6. We also had a term that did not cross out. The x plus 3 did not cross out. That's still a variable expression in the denominator. And so we have a vertical asymptote at x equals negative 3. And you get that by setting x plus 3 equal to 0 and solving. And we were writing it like this for a while, and that's true. X cannot equal that, and that's why it's a restriction on the domain. But when we talk about the vertical asymptotes, we're actually going to be graphing this line, so we want it to be an equal sign when we state it as the asymptote, because x cannot equal that. So we kind of go back and forth with that. But when you're stating it, use a regular equal sign, and it comes from what's going to make this 0, and an x value of negative 3 does. For the horizontal asymptotes, we need to compare the exponents of our original function here. We have x squared, x squared. That means they are equal powered, and so we use the numbers of the coefficients, which is 1 over 1, so we will have a horizontal asymptote at y equals 1. Because we have a horizontal asymptote, that means we can write none for a slant asymptote. Now for the x-intercept, we want to know what will make the numerator 0. So that's x minus 4. Let me just do this work over here. X minus 4 equals 0. Finding the roots of this, We probably don't need to show a lot of work for that, but if it was a little bit more complicated, we could type into our calculator and so on. But what makes x minus 4 0? 4 does. And so you're going to have an x-intercept of 4 0. Remember, for y-intercepts, what we do for the y-intercepts is we replace all of our x's with zeros. Just like when we replace them with 3's for the whole, we replace them for zeros. So that would be 0 minus 4, and 0 plus 3 leaves you with negative 4 over 3. And so that is your y-intercept of 0, comma 4 over 3. All right. And so you see there's an extra line down here for extra points, but I'm gonna get those from my calculator. So let me just first put down what I have on here. Now we'll see how this goes. I've never tried graphing with this tablet that I'm using to write on, so excuse me if it's a little sloppy. But first I want to start by graphing my asymptotes. So x equals negative 3. Here's negative 3. And so it's going to be a vertical asymptote at negative 3. Here's x equals negative 3. And asymptotes we always draw as dotted lines. A horizontal asymptote at y equals 1. Here we go. Then we have a couple of intercepts. It's probably the next best thing to do. So we have an x-intercept at 4 0. So that's right here. Make it a nice big point. And 0 4/3. Now 4/3, I'm going to have to estimate 4/3. I can type it to my calculator. It's about 1.3 repeating. So 1.3 repeating is roughly about there. So that's my x-intercept, my y-intercept. And then I also have a hole. So 3 comma negative 1/6. And the way to graph a hole is by drawing a hole. So it's not a filled in coordinate. It's going to be a circle basically at that spot. So 3 and negative 1/6. And so that'll be a hole in the graph about there. All right, next, I really want to do pretty much the work from here in my calculator. So let's pull up our calculator, and let's, excuse me, let me just move this over. Type in, and you're going to type in your original equation. So we'll go to y equals, parentheses, x squared minus 7x plus 12, close parentheses, divided by, open parentheses, x squared minus 9, close parentheses. And let's take a look at what it looks like. All right, so it's good to have this next to us while we're graphing so we can kind of get a sense that make sure our picture looks kind of like what this does. We see we have a vertical asymptote that's here and the horizontal asymptote that's there. So that's all good. Now let me take a look at my table. I can do second graph to get a table and see if there's just any other good points I could use in here to kind of plot on my graph. And anything whole number would be great. And you're not always going to find them. Sometimes you're going to have to plot decimals, but anything 0.5 is good. So I see right here negative 4, 8. So that's a great one. So let me go over here and list that. Let's see, we got negative 4, 8 is one of our extra points we can use. Notice that negative 3, it says error. That was because we have a vertical asymptote at that spot. Negative 2, negative 6, that's a couple whole numbers. That'll be good. Negative 2, negative 6. And just list a couple of them. Negative 1, negative 2.5 is good, but since I already have a few over there, I probably don't need any more. If I could find some in this spot, again, look at positive 3. That's because I have a hole at positive 3. That's why it says error there. I see my x-intercept 4 zeros here. Now, I'm not going to be able to find my y-intercept 0 4/3, but I could always turn my table into, this is just a good way to check what your y-intercept, turn that into ask when we go to the table. If I do 0, it's going to give me negative 1.33333. And so that's your 0, that's your y-intercept. Now, why does that say negative, but mine says positive here? Did I make a mistake up here? I think I do. I do remember it kind of being negative, and my graph is covering it over here. Oh, see it? It is negative 4/3 here, but I wrote it as positive 4/3 when I went down here. So I say that's a good reason why you should type it into your calculator and see if it comes up accurately. So 0, negative 4/3 is my y-intercept, not positive 4/3. So that's actually over here, 0, negative 1.3. That's important because that would have messed me up if I didn't catch that mistake right there. Okay, so let's see. Were there any other good points? Now I got to change my calculator back to auto. Go back to the table and see if I can find any other good points in this range. Nothing standing out. I mean, 11.5, but that's going to be pretty. I think my graph only goes to 10 in each direction, so that's not too helpful. 7.3, maybe I could do that one. I could use that one. 7.3, let's write that one down. 7 comma 0.3. And so let's plot these points also. Let me use these in a different color. These were my special ones that I plotted here. So negative 4, 8. I need to move up. So negative 4, 4, 5, 6, 7, 8 right here. And then we also had a negative 2, negative 6, 3, 4, 5, 6, and then 7.3 is about there. Now, okay, take a look at what my picture looks like. You can get kind of a sense of what's happening here. So you need to just draw the best sketch you can, and using the asymptotes as a guide. And so this one, I'm going to make sure I go through that point, go through that point, and then you do use the hole as kind of like a gap. And excuse my sloppy curve, but that'll do. That's about it. So that's graphing a rational function, putting everything together we've done. Using the calculator is very useful to check your intercepts in the table, turning on to ask, but also taking a look at the picture in your calculator and seeing if your picture is going to match up in the end. You kind of see that these do. And so the calculator is very useful also to get a couple of additional points to help your graph be that much neater. All right, so we'll practice this for a couple of days. See ya.